Okay, so we are going into the lecture on regulations, and it's always a good idea to start from terminology to fix it and know what we are actually talking about. But here comes a joke, which I make in almost all the courses I teach, so I apologize to those who may hear it from me or otherwise not for the first time, that there are two problems in modern science. One is that very often the same term is used for different things, and the other is that the same thing is very often called with different names. And this is true everywhere, and in particular within UTM UAM. So the terminology hasn't been set, and I'm not sure if it ever will be fully agreed. On the other hand, the good news is that it actually creates not too much confusion. So people more or less understand what they're talking about. And if there is confusion, then there is always a possibility to discuss things and zoom in on a particular definition so that it suits, so that everybody understands it in the same way. So yeah, just as a general encouragement, it's important to ask a search for terms if you don't understand it. Of course, it's true everywhere, but in particular, when you're talking about something as novel as UAM UTM, that's important. Do go and look at the terms and see what they really mean. We will cover, of course, the terminology in this course as needed, but we will not start, from looking at some kind of list and trying to memorize all the different things. There are many lists of terms that exist, but I don't think there is one which would be, accepted as a ground truth worldwide. On the other hand, if we speak about abbreviations, I think they are pretty much non-confusing and worldwide accepted. So what is worldwide accepted is what any particular abbreviation, how it is expanded. They may still mean different things, and we'll look at the examples, but at least in terms of whatever particular sequence of letters means, the abbreviation, or is it sometimes called the initialization, when you take the initial letters and form an abbreviation. So the expansion of the abbreviations, the expansions are more or less fixed. So in particular, the two most important ones, the UTM, which is unmanned traffic management. Well, it's unmanned aerial systems traffic management, and in more details, we'll look into that. But anyway, that's about management of traffic. And UAM is urban air mobility, nothing else. So the expansion of the abbreviation is fixed. There is also something called advanced air mobility. I think it's more of a US term, used by NASA and I guess introduced by the FAA, and it includes not only urban but also rural. And if you look at the definition from the FAA, yes, so it speaks about urban and suburban areas, so maybe not that much rural, but again, there is a separate, really important and interesting question how to classify the areas into urban, suburban, and rural. There are OECD definitions. If you want to delve into that, I can give you a full, full set of documents and algorithms and stuff like that. And maybe teach a separate lecture, but not within this course. Okay, so there is UTM, UAM. There is also AAM. And well, if you look at the Wikipedia, which may or may not be the best source, for everything, it says that urban air mobility is the same as advanced air mobility. UAM is equal to AAM. In principle, okay, sorry, going back to the wiki page, it says that urban air mobility is about transportation of people, of passengers. But if you look at the EASA definition, it speaks not only about people, but also of goods, so goods and passengers. So even there you have, some, I wouldn't say it's discrepancies, but if you really want to go into the details, then yeah, you may spend lots and lots of time arguing whether urban air mobility is the same as advanced air mobility and whether the goods logistics are included into them or not. Another interesting moment is that EASA speaks about the electric aircraft with vertical takeoff and landing, VTOL, while in reality, as far as I know, maybe purely electric aircraft are not seen from day zero, so there will be hybrid aircraft. Hybrid doesn't necessarily mean that you will use fossil fuel, maybe all these new ways to use hydrogen in a safe and efficient way. But anyway, possibly not only electric vertical takeoff and landing aircraft. So not only electric, and also not necessarily strictly vertical. There may be also short takeoff and landing. I mean, the aircraft which use very short runway and then take off more or less vertically. And EASA itself produced a video, which I'm not going to show you, but in the, well, there is a link to the video. And in the end of this video, they're showing some envelopes, yes, like this, for the possible vertical profiles of how the aircraft take off and land. Again, no need to watch it unless you're interested. Just here again, just this more or less speaking about the definitions and terminology. And of course, the bad news is, well, that's a bit confusing if you go into details what do really different people mean by the different terms. But the good news is that really the boundaries between the conventional aviation and these novel disruptive technology, drones, urban air mobility, and stuff like that, these boundaries become more and more fuzzy. You know, okay, urban air mobility or advanced air mobility encompasses everything: rural, urban, suburban, hybrid, electric, VTOL, STOL, whatever. And eventually, with the larger drones, you come in closer and closer to conventional aviation. Conventional aviation also comes closer to electric. There are aircraft which are being certified. They are smaller and smaller. Where is the boundary between conventional and urban air mobility? I'm not sure, and maybe it's good that it's hard to even understand where this boundary is. Maybe they will blend into something, you know, whatever it will be called, a new type of aviation, integrated management of different kinds of traffic. So all in all, don't worry too much about the terminology. It will somehow come to good grounds, whatever the end result will be. So just to look at the one particular abbreviation, of course, UTM is important. Okay, it's if you look at the definition, it's UAS traffic management. And of course, UAS is an abbreviation itself, which is unmanned aerial system. There are also other abbreviations like small unmanned aerial system, small unmanned aircraft, just unmanned aircraft, unmanned aerial vehicle, UAV. We used to use this term a lot, still used. Remotely piloted aircraft system, RPAS. Yeah, I mean, there are many documents that use RPAS for remote pilot system, and so on. I will be loose, and I think we don't really lose any generality by just calling these things drones. And again, I know that drone has different connotations. Something that, while drone is necessarily this military thing, which is killing people, but it doesn't have to. I mean, I'm fine with the term drone, but if for whatever reason you want to use some other term out of listed here, or not necessarily listed here, that's perfectly fine. If you really want to go into details, you may want to use one or another, but at least for the purposes of this course, any of these will work fine. Now, I put here all these equality signs, but really these are, well, approximately equal. If you do go into the nitty-gritty details, well, the unmanned aerial systems, the system is not only the aircraft, but also some ground support systems. And I'm just hearing it more and more that unmanned is called uncrewed, to kind of distinguish between the remote pilot and the pilot on board, and so on. So again, this is just to say that the terminology hasn't been settled, but if there is no confusion, that's fine to use any of these terms. Now, one important term is the U space. And well, as far as I understand, and you will see this in my humble opinion, things every so often in the course, and I apologize for, well, just putting in my opinions instead of something which is solid. As I said, it's a changing area, and definitions and terminology is changing. But to me, I would say that U-space is the European analog of UTM. So UTM, the term was coined by NASA, and if you look at the definition of it, well, it's, as we said, UAS traffic management system. They had this UTM project. It will come up more during this course. Well, UTM is in the name of the course. Now you look at the definition of EASA, U-space, UAS traffic management, completely equal to the definition of UTM from NASA. So, well, I guess I have the reason to say that U-space is the European analog of ATM. At the same time, when or as we'll speak about regulations, of course, EASA has the final word. EASA is, well, it's a very important body. As you know, it's an abbreviation in itself, but I guess you know what it is, European Aviation Safety Agency, which issues regulations. And in particular, as already mentioned, and as you may know, in April 2021, EASA had the regulation on U-space, regulation 664. And in 664 and also 665 and 666 as amendments to some previous ATM regulations, EASA has definitions of U-space, well, or more specifically of U-space, airspace, and U-space services. So here are the definitions that U-space, airspace, well, is a certain area where you have to fly with the support of U-space services. What is a U-space service? Well, U-space service is a serving which relies on computers and so on and so forth to support lots and lots of operations in the U-space airspace. And if you got to wonder, just as myself, well, where do we start from? You know, this is not a perfect mathematical definition where you have some undefined terms, you know, like think of geometry, point, line, they're not defined, and then you operate with them. So here you're trying to define U-space airspace, and in the definition of U-space airspace, you're using U-space services. So you're saying, aha, before I know what U-space airspace is, I should know what U-space service is. And you look at the definition of U-space service, and it uses the definition of U-space airspace. And you can probably create an infinite loop in the recursion saying that U-space airspace is something that uses services relying on the blah, blah, blah to assess U-space airspace, and instead of U-space airspace, substitute the definition of U-space service, and so on. So I wouldn't say that's an ideal definition from purely technical or mathematical point of view, but nevertheless, I mean, it's a definition. Oh, these are two definitions. They are fine, and well, they may change, and the regulations may change. They may be amended, and so on. And there are certain, I don't know if I should say gaps or certain questions within the regulations, in particular, you know, within Regulation 664. But definitely, having a regulation is much, much better than having no regulation at all. The state in which we were in before April 2021. One reason why I'm particularly happy about EASA issuing the regulations for Europe is that, well, in this course and in general, I don't have to look at the different similarities between all these rules and regulations in different countries, which is in the description of the course. And if you really want to go and see elsewhere in the world, you know, in the US, Japan, and Canada, see how things are different from EU, that's fine. But for the course, using EASA regulation, using European rules are perfectly fine. So a very good timing for the course, or I would say for the regulations. We now know what to study. Okay, so returning to the terminology, abbreviation, and other notions, sources. Again, there are quite a few places from which you can get them, but you should understand what sources have higher priority what have lower priority. Of course, the EU laws are the most important. I'm not an expert in, I'm not a lawyer, so we don't cover these in the course, and I don't know if they contradict to EASA regulations. Hopefully not, but if they do, of course, I mean, you have to abide by the laws. So here I have this list of possible sources, and I put in bold those that we use in the course. The highest priority for us has EASA regulations. They have the highest priority, including the acceptable means of compliance and guidance materials to the regulations. And these things into which we will look and have examples even during this set of slides, they are good because they really explain the regulations, make them more clear, show pictures. I will show just pictures from AMCs and guidance materials. And the more of these you have, to more regulations, the better it is, the more clear the regulations are, the more understandable they are. So yes, regulations are the top priority for us. Then there are research articles. I mean, we write research articles. We try to be as precise and formal as we can in them. We do challenge the regulations sometimes. So whatever is in the articles, that doesn't have to be any kind of rule, but still a lot of thought is put into research articles and other work in research projects. We will be using some of those. Well, regulations are more important, but articles are still good. Then there are different concept of operations. In particular, there was, it's finished now, the project concept of operations for European New Space, or something, Chorus. They have the concept of operations. They have several versions. The third one is the final one, very well thought. Among many concept of operations, I would say this is probably the most relevant one, at least for Europe. I will have you know, a list of other canopses in a future lecture, but we will not go too deeply in any of those, and even will not go too deeply into the chorus canops, because yes, they are superseded by regulations. You know, canopses are so many. There are many. I think they're still coming out. But I was quite happy that the regulations are there, because otherwise I would have to teach from the canopsis. And of course, you should also be happy, because you would have to look through lots of canopsis instead of looking through few regulations. And I'll have a list of regulations on U-Space and on drone operations. As we already saw, that some of them are large, but it's a finite set of regulations. They are not changing. Unlike with canopsis. Canopsis are not bad. It's good that people are thinking and designing concept of operations, but regulations are more important. Now, speaking of urban air mobility concept of operations, so this project, Chorus extension to urban air mobility, is still going on. We are taking part in it. In fact, I briefly joined in the break. I briefly joined the meeting, which I'm missing because of this course. Anyway, it's not there yet, but it's in the works. So regulations, most important, research articles, CONOPS, not so much, but sometimes. Well, there are also EU standards, which we don't look at. ICAO, mostly for the conventional aviation, we don't look at that. FAA, I mean, we had the definition of AAM, and NASA, anyway, things from the US are less relevant for us in the European context, but of course, very interesting. News, social media, you know, articles in on the internet, why not? I am using it. Well, and people report and on what they have done. You look at the articles. It's not bad. You just have to understand that it's not the final word, that there is really different priorities and relevance of different sources. Hopefully, the main idea is that regulations are most important. So here they are, the relevant regulations. The 945, 947, pretty long read. I guess we looked at these easy access rules, yes, which are nicely organized on the webpage. We will look at them many more times. They are easier to read, or at least subjectively for me, than the regulations themselves. I've read the regulations. Now there are also acceptable means of compliance and guidance material, which is right they are right in the easy access rules. Again, very convenient. We will look at a couple of examples down in this set of slides, looking at distance to or from the ground and distance from people for the drones. Another thing, speaking about abbreviations, the easy access rules has this list of abbreviations. I don't want to go through each and every abbreviation right now. We don't have to learn all of them, but it's important to know that they are there. There is also a link on the web page. It's important to understand that it's not an exhaustive list. For instance, UTM, UAV, RPAS, they don't belong to this list, but nevertheless, it's in the regulations. So I think these are pretty much solid. Okay, and last but not least, the 3 regulations on U-Space. So 664, the regulation on U-Space itself. Now, I guess I'll just open it for a second. As I said, no easy access rules or no easy read, but I mean, still readable. I'll ask you to browse through, don't browse through these annexes, how to fill in different forms, but still. And 665 and 666 are really short. I'll just show what they are about on the next couple of slides. And yeah, I'll ask you to read them through. And not much there. Okay, so yes, these are the regulations, and then the remaining slides we kind of go with the reverse order, starting from the simplest one, 666, 665, and then on U-Space and the services, and then go into 945 and 947, and then I will ask you to watch separate video for SORA, which is part of 947. Okay, so 666, 665, let's get them out of the way. This one is about manned aviation in U-Space, amending a regulation on the previous regulation for the manned aircraft. Basically, 2 new points, just to let manned aviation pilots know that, well, there is U-Space with a certain set of services, and you would have to, in certain places, have certain requirements for communication, like radio, which can be mandatory, transponder may be mandatory, and that there exists, yes, U-Space, airspace, a special zone which didn't exist before. And manned aircraft are actually allowed in U-Space. I wouldn't say that what's in this regulation is, you know, the complete and final answer to all questions on how the manned aviation should integrate with unmanned. But more or less, it's saying that, yeah, if you don't have ATC, traffic control services, and if you're electronically conspicuous to U-Space service provider, then you can go into U-Space. So if you're a manned aircraft, but you have a means to inform the U-Space about yourself, then okay, welcome in. And you know, it's a minor point in a small addition, well, small amendment to a regulation, but to me personally, I think this is a very important point. So again, speaking about the boundary between, you know, here are the manned aviation, here are the unmanned, conventional versus drones and stuff like that, I feel that this really, if not fully, clears up the boundary between, you know, conventional and then the new aviation. It kind of welcomes it in. We no longer require separation, you know, that the conventional large aircraft stay here and the drones stay elsewhere. We are going towards the integration and having a single system. Possibly it will be U-Space, possibly it will be some other merge of U-Space with the traditional air navigation services, where both the manned and unmanned aircraft will coexist and you know, will fly conflict-free. All that matters is that you manage the risks. You wouldn't have to, you know, then it's good, because all these definitions would be gone. I wouldn't have to understand, do I belong to UAM or do I not belong? Am I piloted or not, crewed or uncrewed? Am I a remote pilot or whatever? If I have enough equipment to be conspicuous, to let the U-Space know about myself, if I have enough to manage the risks, if I've done all the necessary certification and so on and so forth, then, well, I fly in the U space. And maybe it doesn't matter so much whether I'm a small drone or larger aircraft. So we are not quite there yet. I don't think that, well, all the questions are answered. But anyway, this small amendment, I think it's a step towards something very good, or in any case, it's a good step, and hopefully towards something good. But that was it about 666. Now 665 is also a small amendment to Regulation 373 about air traffic management and air navigation services. It gives the definitions of U-space and U-space services. I mean, we saw it also in 664. It speaks about this common information service and dynamic airspace configuration. Again, we don't go too much in the details in a lecture. I guess there is a homework question where I ask you to look at one of them. So more or less it says, yes, again, you have to coordinate with air traffic control within the U-space and reconfigure the U-space if there is a demand from the manned aircraft coming. So you have to provide traffic info on manned aircraft in U-space. In principle, they are possible, as we know. Well, you have to coordinate between air traffic control and U-space service providers. Yeah, because of the manned traffic demand, the U-space may have additional constraints, and air traffic control units should make sure that they're appropriately known and done. And yes, again, the U-space service provider has to communicate through this common information service, explain what kind of U-space has been activated, deactivated, what boundaries there are, what constraints, what limitations. Anyway, I guess they're more or less repeating the same story. Coordinate, communicate. So that's it about 665. And in the remaining 15 or 17 minutes, let me try to explain some stuff from the bigger one, from the Regulation 664 on U-space. So again, recall the definitions. You can look the exact phrases in the regulation or above in these slides. U-space airspace is where you have to use U-space services when you fly in it. And U-space services are the ones that make sure that a lot of drones can access this U-space airspace in safe, efficient manner. Okay, so what are these services? What are the U-space services that serve this wonderful purpose? Now, there are 4 mandatory services specified in the regulation, and they are network identification, geo-awareness, flight authorization, traffic information. In addition, if the government, the member state requires, or the competent authority, I'm not sure what kind of government, if the competent authority, National Aviation Authority, requires, you also have to provide the weather information and conformance monitoring. So these are the services in the regulation. In ConOps, you can find many, many more services. Of course, people are thinking about other services. So it's probably not only these 4 or these 6 that would cater to all the possible needs, but nevertheless, these are 4 mandatory, and these are 2 that can be requested. And in very short descriptions of what they are, so network identification should tell who is flying, where they are flying, and in which direction. And this information should be shared with other airspace users. So who is where? Geo-awareness are the airspace constraints and these zones for the drones. So where can you fly? So network ID who and where is flying, geo-awareness where you can fly, under what constraints. Flight authorization, you have to be authorized for conflict-free operations. So only those operations that are conflict-free should be authorized. And the traffic information service, it alerts about other traffic in the vicinity. So I don't know, these explanations, they are short, but I guess the namings of the services are pretty good. So they more or less explain what they are or what you have guessed. The 2 non-mandatory services, weather information, should help with other services, in particular with flight planning and with actual flying. Again, no surprise. Conformance monitoring, yes, what it is. You have to provide real-time alerts if the flight authorization is not conformed with. So again, I think the names speak for themselves. This time I'm pretty happy about the terminology. And to know about services in detail, I encourage you to browse through the regulation 664. Again, only the core of the regulation. You have this homework problem. Browse through 664. As I said, it's pretty large, but it's not too large. Not an easy read, like for these ones for 945, 947, which we will look at next, but nevertheless, hopefully from going back one slide from the names of the services themselves and also from short descriptions, you understand what they do, so no surprises here. And yes, you look into some details, but you don't have to really memorize what they're doing. Don't have to memorize specific performance requirements or any numbers. Again, just to emphasize, the course goal is not really to learn all the regulations. I'm not doing lawyers out of you. Of course, if you go to the industry and on your job you work with regulations, you will learn regulations. You will learn them much better than I do. Maybe you'll come back and give a guest lecture here. But more important is that you know what regulations exist, what they are about, and where to find the information. I mean, in digital age, you go to the regulation, just search, control find for, if you know the right term. So that's about 664. And last but not least, we go into 945, 947. So these are from the easy access rules. So they are very much about risk-based approach, as I already mentioned before. They look at drone specifications like weight and wingspan and, well, it has wings, or this largest dimensions of the drone, looks at the specification operations and tries to understand what kind of risk the drone poses. I'll give some details. Important, it doesn't look at really the type of operation. So what exactly you are doing is not the regulations business. Are you doing some business? Are you just doing some photography and so on? And this is actually very good. I mean, this risk-based approach, I think, is the right approach, as we already discussed. It matters what kind of equipment you have and what exactly you do, but the purpose of the operation, it doesn't care. That's good. We don't try to understand what exactly people want to achieve. It is their business. Good. Now 945 is out of our scope. As I said, it's more for manufacturers. 947 is something we look at with some details, also at its acceptable means of compliance and guidance materials. Basically, it defines three categories of drones. They're all based on risk. Again, risk-based approach, that's what it is. So open is the simplest category, lowest risk. It also divided into few categories based on what kind of operations, what kind of pilot, what kind of drone. We don't go into details. You know where to find them. We will go into some details again to show you a specific place of where to find something. But anyway, so these are low risk. I'll have a picture on the next slide. These are a bit higher risk, very wide set of operations. We'll go into details. And certified is, well, very high risk. You really have to be certified. You have to be like the conventional aviation. Here is the picture, which is probably worth more than whatever words I said on the previous slides. Yes, so open, low risk, quite a few limitations on what you can do, but you can just go ahead and do it. Specific is higher risk. We look at the risk assessment, and certified, I mean, it's like a manned aircraft. It's completely outside the scope of this course. We don't look at the operations in certified category, even though the SORA, the specific operations risk assessment, which we will look at in the details, it does have a clause which says it's particularly tailored to specific operations, but it can also be used outside of specific. But anyway, I just read SORA and found this particular statement. I don't think anybody cares too much to apply SORA to certified. Certified is certified. It's think of large usual aircraft with hundreds and hundreds of pages of certification. Okay, so as I said, certified is out. Specific we will look at with some details. For the open category, let me just give a couple of examples of why acceptable means of compliance and guidance materials are good. One is this distance to the ground, at what height you can fly. So again, I have some links to the easy access rules. And well, there is some text that describes where you can fly and so on. And you see this number 120 meters and 15 meters and so on. If you look at the guidance material for it, it has a picture, and picture is wonderful. And I'm sorry for the quality. Okay, picture is wonderful, but the quality is not wonderful. This is how it is in the guidance material. It's not because I blurred it or anything. It's upon the request of the owner of this obstacle. Anyway, that's something you can read in the text. But yeah, here's a picture. And it's good. You more or less understand, stay 120 meters away. And if you have a tall obstacle, you can fly over it in 15 meters. Stay VLOS, visual line of sight operation. And above 120 meters, there are no drones, and so on. So you decide whether this picture is worth the 1,000 words or whatever number of words in the text. But again, most important is that we go into the regulations and try to read and dissect all the words when needed. You wanted to know about the height, you browse through the material, through the easy access rules. You see this picture, okay, you understand something, and then you see, okay, so this is the guidance material to what? Well, to a certain thing, US Open 010, which, yeah, I guess the whatever general rules, whatever these are. Yes, let's see what they are. General provision. Yeah, general provision, general rules, or whatever. I don't have to remember what it is. I see the picture. It points me to the guidance material, to some specific thing, to general provisions. And then I can go up and search. Okay, so here are the general provisions. And here is the text that this guidance material is expanded on and explaining. It has a picture. So guidance material are good. That's the point. It again helps the goal of the course, know where to find information rather than really know all these numbers. I mean, there is also, okay, so this picture doesn't show that what is the envelope, sorry, what is this envelope, what is the distance from the artificial obstacle within which you can fly 15 meters above it. Well, you go into the regulation itself, and it says, okay, within 50 meters, at the horizontal distance of 50 meters is where you can fly up to 15 meters above. And the obstacle has to be taller than 105 meters, so that altogether you're at most 120. But again, you don't have to learn this full regulation. You look at this picture, if there are some questions, go to regulations. Hopefully it answers all your questions. Okay, another example, a similar one, distance to people. Again, there is some regulation with some text, how far you should stay from people. And unlike the previous one, which was this general provisions, this applies to subcategory A2. I don't want to go into details what subcategory A2 of the open drones is. Go into the regulations, find what they are. Now you know that there are subcategories. You will see what are the characteristics to go into subcategory A2. But anyway, for this subcategory, yeah, there are some regulations on how far you should be from people. Here is the acceptable means of compliance. A picture, yeah, it tells you that yes, you have to have this one-to-one rule. So if you're at certain height, you have to the same distances where your impact area is. So this is more or less 45 angles. It's also in SORA in the risk assessment. Yes, this distance. Yeah, and I wanted to do the 45 angle, but sorry for my drawing. Again, this is a picture which says what is the impact area. Yes, what are the exceptions, and so on and so forth. Whether this picture is particularly helpful, again, you decide, but if it's not, you go back and you read the text. And in the homework, I actually ask you to go and read the text and solve a specific problem. Okay, so just a couple of examples before we go to certified. And the last couple of slides, I will kind of warm up you to a certified category, asking you to watch the SORA video in the end. One thing that I find an open question, and open here doesn't refer to the open category, it means that unanswered question. As far as I know, for instance, I couldn't see what are the regulations on how far you should stay from people for specific and certified categories. Okay, so that I just don't know. Don't ask me. If you find the answer, let me know. I'll be interested myself. But all in all, okay, so we will stop doing toy drones, pun intended. No more open category. Certified we don't do, that's too complicated. We go into the specific category. And specific category is, it's a very good and very broad category. It was, well, pun intended, specifically designed to cover lots and lots of possibilities for drone operations. Of course, it's good that it is so wide, but if you want to do the risk assessment for such a broad set of operations, it's pretty complicated, as you may imagine. So you have to cater to lots and lots of needs. You have to go through quite a complicated process, multi-step process called SORA, Specific Operations Risk Assessment. Of course, in general, how do you solve a complicated problem? You break it into parts. And when it comes to risk assessment, you break it into air risk and ground risk. That's what SORA does, and that's what I will speak about in the quantitative risk assessment. But still, staying with the regulations, there are several ways in which you can get approval. And I will go bottom up. You can get something called Light UAS certificate. If you are so good that you can prove to the authority that you can do operations safely, then you can just go and start operation. If you get this certificate, Light UAS certificate. If you are not, then you can do something called standard scenarios. Again, here is a link to the corresponding regulations. I mean, all of them are in 947, but in different places. So with standard scenarios are something that was developed before you, and you don't have to do risk assessment. You more or less declare, I'm starting one of these standard scenarios. And then the authority can check whether you can really do it or not. But again, no approval is needed. There is something called predefined risk assessment. Again, it's not one of the standard scenarios. And in standard scenarios, I think there are 2 or maybe 3, so not covering everything. But so if you are not doing a standard scenario, but nevertheless somebody did risk assessment before, then you can do the predefined risk assessment. It still has to be approved by NAA, the national authority, their regulator, Transportstyrelsen in Sweden, by the way. And the last but not least, if you are kind of starting from scratch, the most general thing you can do is to do SORA. And yeah, it's a multi-step and involved process. And here is an example of SORA step. Intrinsic GRC, you will look at the regulation. I will just quickly go through it. You have a drone with certain dimensions and flying a certain speed and a certain mass. So you know what is the kinetic energy of the drone. And you see that with this kinetic energy and with this dimension, you're falling into a certain class of drones. So you look at this column, and then you look at your operational scenario, whether you're flying over populated or non-populated area, visual line of sight or beyond visual line of sight, you don't see your drone. And in the intersection of these two, you find the intrinsic ground risk class. Okay, so I went over it very quickly, but you'll have to do more of it in the homework and see how it's done in SORA. And the last but not least, the last slide. Yes, SORA is most frequent, multi-step process, I think I said. What you have to do is you have to browse SORA documents, learn to calculate, as I said, intrinsic ground risk class, one particular step in SORA, and watch this SORA video. It's about 1 hour. You can also optionally watch the EASA regulations summary presentation. I gave specific the reference to specific minutes in a webinar. That's just a summary. Do it when you want, and I'll